This is systematic equations. We're going to talk about a reaction like this. I'll start with something really simple. CaF2, we all know, is a slightly soluble salt, and so it's in equilibrium with calcium plus 2 and 2 fluorides. It has a KSP, which we know is the concentration of calcium plus 2 times the concentration of fluoride minus squared. You got to be a little bit careful here. It's really activities, but I'm going to use concentration in my symbols all the time. The problem we have is with our fluoride. The fluoride, F minus, can also react with water to give us HF. It's a weak base, conjugate acid-base pairs here, F minus and HF plus OH minus. Now, Le Chatelier's principle comes into play here because what's happening is I'm removing fluoride in this reaction. So the calcium fluoride reaction is going to tend to go that direction. And because I'm removing fluoride here, Le Chatelier says it will go that direction, which makes more fluoride, which puts more fluoride in here, and which means this one's going to go more. So Le Chatelier's principle's coming into play here. So let's just write our equation down. I have an equation for this Kb is equal to the concentration of HF times concentration of OH minus divided by the concentration of F minus. I can't help you if you can't figure that out. That's equilibrium expressions. We've been doing them since freshman chemistry. I also have one other equation, the really familiar water-water reaction that's always in there. And that gives us H3O plus OH minus. And I know the equation for that, Kw equal to concentration of H3O plus times the concentration of OH minus. So I'll count up my unknowns right now. I'll do them in red. I have calcium, I don't know what it is. I have the fluoride concentration. I have HF, I don't know what it is. I have OH minus, and I have H3O plus. So I have 5 unknowns. That requires 5 equations. So I got to come up with a couple equations. Now, right away, I notice that the calcium and the fluoride are related because the only source of calcium and fluoride are from the calcium fluoride. So they have to be a 2-to-1 ratio there. So what I know is there's always 2 times as much fluoride as calcium. So I can make this 2 times the concentration of calcium plus 2 has got to be equal to the total fluoride concentration, which would be fluoride minus. But some of the fluoride went to make HF right here, and so I have to add that in, plus the concentration of HF. I have the 2 over here because the fluoride is twice as concentrated as the calcium. So there's another equation, and that's a nice one because I didn't add any unknowns. And there's a final one. It's called the charge balance. So this is the mass balance. Now the charge balance states that all the charges must add up to 0, okay? Otherwise, you get electrocuted when you touch the solution. So I'll take every charge, I'll take the positive species and put them on the left-hand side, and I have calcium plus 2. I'm going to leave a little space there because I'm going to come back to that, and that has got to equal the concentration of all the negative species, which I have 2 of those, OH minus and F minus. Now, here's the deal. For every calcium atom, I have plus 2 charges there. So if I have 1 calcium, I get 2 positive charges. If I have a fluoride, I only get 1 negative 1 charge. Only 1 charge for the fluoride. Likewise with OH, I only get a negative 1. But the calcium gives me 2 positive charges. So this is concentration over here. It's not charge. So I note that the concentration of calcium, the charge is going to be equal to 2 times the concentration of calcium. Every time I have 1 calcium, I get a plus 2 charge. So I have to put a 2 here. and that is our charge balance right there. Charge balance. Now I have how many equations? Let's count them. 1, 2, 3, 4, 5, and I have 5 unknowns. This, in principle, can be solved. Right now, you don't have to solve it. You have to set them up. I'm going to do a slightly more complicated one. Let's take a 1 molar solution of NH4S, ammonium sulfide. Okay, so I want to get all the equations and all the reactions that occur. First step is, again, to write the reactions. NH4, 2 sulfide reacts 100%. How do I know? It's an NH4 plus cation, and those always are 100% soluble, so I get 2 NH4 pluses plus a sulfide minus 2. I also know, because I stated it was 1 molar. It is 1 molar solution, and salts, when they go in solution, dissolve. That was another way of knowing that. All right, now NH4 will react with water to give us NH3 plus H3O plus. I have a Ka for that. Ka equal to concentration of NH3 times concentration of H3O plus divided by the concentration of NH4 plus. That's one reaction that occurs. Now I'm going to look at the sulfide. The sulfide can do some fun stuff too. S minus 2 plus water in equilibrium with HS plus OH minus, and that is KB1 is equal to KW divided by Ka2, and that is equal to the concentration of HS minus times concentration of OH minus divided by the concentration of S minus 2. Forgot my minus there. Then the HS minus can react further to give us H2S plus OH minus, and I get KB2, which is equal to KW divided by Ka1, which is equal to the concentration of H2S times concentration of OH minus divided by the concentration of HS minus. Okay, so I got Ka1, Kb1, and Kb2. I have the water-water reaction. Can never forget that. The water-water reaction gives us H3O plus OH minus, and that gives us Kw equal to concentration of H3O plus times concentration of OH minus. And so now that's all the reactions that I can find. So I'll start counting my unknowns. There's 1 NH4 and S minus 2. I have an NH3 here, an H3O plus here, an S minus 2, an HS minus, an OH minus. I already counted HS minus. I got H2S. And so what do I have? If I count those, 1, 2, 3, 4, 5, 6, 7, 8, oops, 7. I counted the S minus 2 twice, counted it here and here. So only 7 unknowns. Unfortunately, I have 1, 2, 3, 4 equations over here, so I got to come up with 3 more equations. Well, we can try our charge balance. Again, that's easy to do. H3O plus the concentration of NH4 plus is going to give us equal to 2 times the concentration S minus 2 plus the concentration of HS minus plus the concentration of OH minus. That's one equation. Need 2 more. Well, I have 2 mass balances. I said it was 1 molar, which means up here at the top, this total should be 2 molar, and the sulfide should be 1 molar in all their forms. So I go 2 molar is equal to the concentration of NH4 plus the concentration of NH3. Those are the only sources of it. And I can say 1 molar is equal to the concentration of S minus 2 plus the concentration of HS minus plus the concentration of H2S. And there I have it, 7 equations and 7 unknowns. Again, we're going to solve these eventually, but we're going to take special cases of it. Right now, I just want you to be able to set them up, okay? If you can set them up, you'll get a lot of credit. That's it.